All right, welcome everybody. Let's do this final lesson within our nice little book here. We're at lesson 30. Let's do this. So, what is the geometric effect of the following matrices? So, try and go back in your notes and look back. What do these matrices do to the unit square or to any other points within the coordinate plane? Okay, so here, if you're coming back to it, this would just be a pure dilation of scale factor k. This one would be a pure rotation, and this one would be a pure rotation of theta degrees counterclockwise. Okay? So these matrices, we've seen these throughout the lessons. Yeah? Okay. Let's go to part B. It says, Jadavis says that the identity matrix is 0, 0, 0, 0, and Sophie disagrees and states that the identity matrix is 1, 0, 0, 1. Their teacher, Mr. Kuzi, says they are both correct and asks them to explain their thinking about matrices to each other, but to also use a similar example in the real number system. Can you state each of their arguments? Okay? So what I want you to do is take your time and try and think about what does this matrix represent here, and what does this matrix represent here, and how is it connected to the real number system? So here 0, 0, 0, 0 is the same as 0 in the real number system, and that's the symbol for the real number system. And this 1, 0, 0, 1 is the same as 1 in the real number system. Okay? Here, this would be the additive identity, and this will be the multiplicative identity. Okay? Identity. Right? Let's move on. Here, Mr. Kuzi then asks each of them to explain the geometric effect of their matrix would have on the unit square. So here, like this matrix here, what does it do to your unit square? What does this matrix do to the unit square? So take a second and just try and think about what would happen. Here, let's move the camera a little bit. Okay, wait. This. Oh no. And okay, so here, what would this matrix do to the unit square? It literally just brings everything back to the origin. It would bring this would be the new thing that would happen if I were to multiply 0, 0, 0 to the unit square. It just collapses everything back to the unit square. And here, nothing would change. It would just be the same unit square. Okay? Let's go to the next page. Here, we have, given the matrices below, answer the following questions. Okay, so here, let's fix the camera angle a little bit. And here we are. So here, how do I know if a matrix, which matrix does not have an inverse? Remember, a matrix will not have an inverse if the determinant is 0. Okay? So if the determinant is 0, there is no inverse. So let's look at A. And let's just remember that what is the formula for inverse? The formula for determinant. Determinant of A, right, is going to equal 2 times 4 minus 3 times 1, right? Let's have this here. Bam and bam. And let's just remember that if I have some A, B, C, D, the determinant of this matrix, remember it's just AD minus BC, and you're taking the absolute value of it. So here, what is 2 times 4? This is 8. This is minus 3. So here the determinant is absolute value of 5, so it's 5. So A has an inverse. Okay? What about B? Let's look at B. B is equal to what? It would be 5, 2, 10, 4. And then what will be the determinant of B? The determinant of B is 5 times 4, right? So 5 times 4 minus 2 times 10. And then bam, what do we have? We have 20 minus 20, and here absolute value of 0 is 0. Okay, let me fix the camera angle a little bit, and there we go. Okay, so here the determinant of matrix B is 0. So which matrix does not have an inverse? It would be this guy here. B has no inverse. Okay, let's move on. If a matrix has an inverse, find it. So here, if matrix A is not, the determinant of matrix A is not 0, it's 5. So how can I use that information to find the inverse of this matrix? Well, here, what do we need to do? That, let's say if determinant is not 1, right? If I have some A, B, C, D, what do we need to do first? We need to first switch the A and the D, right? So the D comes up on top, and the A is here, and the B and the C just change the signs, right? And then we're going to divide each of them by AD minus BC. AD minus BC, AD minus BC, AD minus BC. Okay? What I want you to do is try and find the inverse of this matrix A by yourself, and I want you to check it as well. Remember, check. Okay. Let's see. Going back to the video, let's say if you pause the video and now you want to see how it's done. Here, let me actually do it on this piece of paper over here. If I have this matrix 2, 3, 1, 4, so if A is equal to 2, 3, 1, 4, right? So what do I need to do? The determinant is not 1, right? What's the determinant of matrix A? It's 5. So determinant of matrix A is equal to 5. So I need to switch these two, right? I need to put the 4 over here. I need to put the 2 over here. I need to change the sign for the 3, and I need to change the sign for the 1. And I need to divide each of them by the determinant, which is 5. Right? We already did AD minus BC. It was right here, right? It would be 2 times 4 minus 3 times 1. We already calculated this. This is 5. So this would be the inverse of this matrix A. Okay? And how can you check? You can multiply these two matrices, right? If I had 2, 3, 1, 4 times 4 over 5 minus 3 over 5, negative 1 over 5, and 2 over 5, if I multiply these two matrices, I better get 1, 0, 0, 1. Okay? And what I want you to do is check it. Check it for yourself. And show that when I multiply these two matrices, I will get that in fact. Okay? Let me just make sure everything is good. And it is. Okay. So this will be part 1 of the video. I'll go to another video to make part 2.